Have you ever wondered how your phone just knows how to finish your sentences? Or how a search engine gets exactly what you're looking for even when you totally butcher the spelling? It honestly feels a bit like magic, right? But it's not. It's math. So today, we're going to break down how computers finally learn to understand our messy, beautiful human language.
I mean, think about it. Computers are absolute wizards with numbers. They can calculate pi to trillions of digits and not even break a sweat. But for the longest time, if you ask them to get a simple joke or, the difference between I'm feeling blue and the actual color blue, they were just completely lost. Or at least, they used to be.
For instance, what's the answer to this? King minus man plus woman equals what? This isn't your high school algebra. You can't just punch this into a calculator. It feels more like a riddle, a philosophical question, doesn't it?
The answer is queen, and what's absolutely wild is that a modern computer can solve this instantly. Now, this isn't just some cool party trick. This is the key to understanding how AI is changing, well, everything, from how we write emails to how scientists discover new medicines. So, how on earth does it work?
To get this whole word math thing, we basically need to throw out a huge assumption we all have about what a word even is. The secret isn't about teaching a computer a bunch of dictionary definitions. Nope, it's about teaching it to see this invisible web of relationships between words.
Okay, the best way to get this is to imagine we're building a new kind of library together. Let's call it an intelligent library. And in this library, we are not organizing things by the alphabet. We're organizing them by meaning. Our entire library is built on one single, really powerful idea from linguistics. It's called the distributional hypothesis, and this quote just nails it. The idea is simple. A word's meaning isn't really in its definition, but in the other words that always seem to show up around it. Context is everything.
Think about a regular library. It's alphabetical, right? Apple is sitting right next to aardvark, which tells you absolutely nothing about what an apple actually is. But in our intelligent library, we've told the librarian to read trillions of sentences and shelve words based on their neighbors. So here, apple gets placed next to fruit, pie, and tree. And croissant is right there next to bread and bakery. They're organized by the company they keep.
So how do you actually build this intelligent library inside a computer? How do you shelve words based on all that context? Well, the answer is to stop thinking of them as words at all and start thinking of them as locations on a map.
See, inside the computer, every single word is given a brand new identity. It's turned into a long list of numbers. In the AI world, they call this list a vector, or an embedding. And this isn't just some random list. It's a very specific, unique address.
I love this way of putting it. Think of it like a GPS coordinate. But instead of a simple 2D map with north, south, east, and west, this is a map with hundreds of dimensions, where each one represents a different little shade of meaning. It's this giant map of human ideas, and every single word has its own precise address.
And this is how our intelligent library actually gets built. Words that are used in similar ways, like croissant and bread, they end up with very similar numerical coordinates, so on the map, they're plotted right next to each other. This is how the computer learns, mathematically, what similar even means.
So how does the computer make this map? Well, it starts with a completely random map, where every word is just thrown in anywhere. It's a total mess. Then it starts reading. Billions and billions of sentences. And every time it sees a word, it tries to guess its neighbors. If it's wrong, it just nudges the coordinates of the words involved, moving them a tiny bit closer to where they should be. And after doing this trillions of times, a surprisingly accurate map of meaning just emerges from the chaos.
Okay, but right about now, you might be thinking, wait a minute. This whole system seems like it has a pretty big flaw. If every single word only has one coordinate on the map, what about words that have more than one meaning?
Exactly. And it's a great question. Think about the word bank. You've got a riverbank, and you've got a financial bank. How can one single GPS coordinate possibly represent two totally different ideas? It really seems like it should break the whole system.
Well, the solution is just incredibly elegant. As the computer is learning the coordinate for bank, it sees it in all its different contexts. So yeah, it sees it appear next to words like river, water, and shore, but it also sees it pop up next to words like money, account, and loan.
And this is the crucial point. The final coordinate for bank becomes a kind of mathematical average. It's like trying to find a spot on a map that's exactly a 1-hour drive from the mountains and a 1-hour drive from the beach. The final coordinate ends up in this mathematical sweet spot, close to both its geography friends and its finance friends. It's like a superposition of all its meanings, all captured in one single location.
So let's just put it all together real quick. We started with this simple idea. For an AI, a word's meaning is all about its neighbors. This lets the computer turn words, these abstract human concepts, into concrete coordinates on a huge map of ideas. And because they're coordinates, we can finally do math with them, solving these crazy riddles like king minus man plus woman equals queen.
And this leaves us with one final, kind of provocative thought. We've seen how computers can map all the relationships in our language. But if you can turn a word into a list of numbers, what else can be mapped? Images? Sounds? What about emotions? What other complex, totally human concepts are just waiting to be translated into a coordinate on a map?